Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Okay, so we are going to talk about, this is North America Math Contest Go Go Go. And I hope you have subscribed the film if you love it. This week we are going to talk about two more ways to determine whether theories are converge or diverge, which are ratio and another way. Okay, so the first one is the ratio way. So the ratio way is based on this, like X is to, AK is to, okay, K is to X. So AK and you are going to divide it into three cases: P less than 1, converge; P more than 1, diverge; P is equal to 1. It is inconclusive. What does it mean to be inconclusive? It means change another way. Okay, change another way. Okay. So in this case, let's give an example about how do we do it. Okay, so let's give an example. Let me think. Here, okay. So we give an example about k factorial. Okay, so this way. Let's use ratio test to solve it. So P is equals to limit k square AK plus 1 k plus 3 divides by k square k. Okay, so you get this in this case, right? And you use cross multiply way to solve it, and you get k square 4 plus k3 infinite. This is infinite. So we know this diverges. Actually, the problem is, how do you know that this is infinite? Okay, so we are going to use the L'Hopital rule, remember? So we know this is infinite to infinite, so we are able to use it. So we know that the derivative of this is going to be this, and what the heck? It's 4x. 3, okay, it's 3x, 3k squared, right? So we know that, and we know 3k plus 1 squared. It is more clear that then you divide this apart. Okay, so it is more clear that it's definitely going to be the, what's that called? Diverge. Okay. So in this case, you just determine how it goes. And then let's talk about another problem regarding this, which is this. Okay. Okay. So in this case, let's talk about how do we solve this, which is we use k divides by k. So, and then we divide, and then we cross multiply, and we solve. So it's 12 k plus 1 divided by 12k. Okay, it is definitely going to be converge to 0. This is definitely going to be converged to this. So this converges. So this is just the way how do we use the ratio test, which recall the formula. AK plus 1, AK. The second way we are going to use it is about the alternating series, which is the last way we are going to use it. Okay. Okay. So let's talk about the alternating series. What is alternating series? Alternating series is a series like this, which is the one that you should be hated the most, right? Okay, like this or this. And AK is larger than 0. If it fulfills two conditions, then it will be converged. First is this. K to infinity. AK. This is the first requirement. The second requirement is this. Let's give an example about the harmonic series. So let's talk about the alternating harmonic series, which is like this. So we know that there's definitely going to be a k. Since we know that the first is positive, so it must be k plus 1. Because if k is equal to 1, then it's going to be negative. So this is k plus 1, and the series are 1k. So let's talk about whether it is. So let's see the two conditions. So this. Yes, correct. And this is less than this. And you are able to see that this alternating series converges. Okay. So what does converge absolutely mean? It means that the alternating this, which means if you change every minus like this, it is also minus to plus. It also converges. So if it does not fulfill this condition when the every minus changes to plus and the equation is converges, then it is not converge absolutely. For example, we have talked about the series. If we are going to talk about whether this converges absolutely, you first change every to plus. And since this, we have proven before that it does not converge. So this does not converge absolutely. Okay. And here we come to the end of this chapter, and I hope you have learned a lot. See you next week. Bye. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!